All right, all right, all right, all right. Let me just check if this is streaming currently. Gotta go into my account and actually take a look at the live stream. Yep, seems like that is working. All right, so the goal of this live stream primarily is to do a bit of testing out the Ralph loop strategy for programming. Um, Yesterday I was saying that, there's this little rotating screen cube in the corner that I built in a single day. It's got some kind of weird transparency issues, specifically because of the way the renderer works. But I don't know. I mean, the plan yesterday was to try and actually finish it out and fix those rendering issues. Turns out it's I don't know. There's the actually I'm gonna write this down. Since they have a name for this file, let's see. I'll just do stream.md in the whole plan.md style. Oh yeah, so the goal is Ralph loop prompting. There we go. So yesterday I was planning on fixing the rendering issues with this cube, but there is something that I have been looking by for a while, actually, and it is very, very much true in this case. There is a 20, or there's an, I'll do, 80-20 split, where it's just the Pareto principle is this principle where it's like a kind of back of the hand estimate, but 20% of the work takes 80% of the time, but 80% of the work takes 20% of the time. And what that means is that it's very easy to just throw up a project that's like 80% there, and the last 20% actually takes like a majority of the time. Or I've heard the way I've heard other people put it is like in the way people talk about like offhand sayings or whatever. Like, oh yeah, the first 90% is very easy. The second 90% is where all the trouble comes in or whatever. And, that's yeah, I don't know. That's kind of how it is. I kind of enjoy or not enjoy it, but the I kind of live by the whole like 80-20 rule, where it's sort of a decent representation because it definitely gives you the like getting 80% of the work done is quite good, and this is 80% of the work and it works. And I'm thinking that this is good enough for now. The actual rest of the 20%, the 80% of the effort is I don't know, kind of boring and kind of just like whatever details stuff. And I don't necessarily care that much, honestly. Like I think this looks cool. It looks neat. The fact that you can kind of see the inside and the outside kind of shifting within this. I don't know. There's something cool to that. So I think I'm just gonna keep this little square here for the time being. Might as well. Anyways, yesterday I talked about homework, actually, how I was going to give people homework. Anyone watching the stream which is currently 0 people. Um, there is a talk, oops, yesterday's, actually, you know what? Yesterday I talked about a talk called, by this dude named Eskil Steenberg. I'll pull up the name of the talk now. Um, you should finish your software. I'll jot that down here. Eskil Steenberg. You should finish your software. And basically, this entire talk, it is amazing. It is by this guy who is one of he's on the C standards committee. He's this like game dev guy who's he's been programming for a very long time. Um, he has his own little skunkworks lab thing where he basically writes C code, and he's been writing C code for over 30 years. That's been his main programming language. And he has all of his life's programs written in C on a public Git repository somewhere, that anyone can see. Actually, I don't even know if he uses. I think he wrote his own version control thing. But basically, the talk starts off with this idea that you can basically invent the universe of code. One person should be able to write all the software that is needed, pretty much. And um, that's a bit of a laughable, or not laughable, but at first when you hear it, you're kind of like, what? That doesn't all software? I mean, like the biggest software companies in the world are like have like, if not billion-dollar market caps, like hundreds of millions of dollars in market caps. They employ like thousands and thousands of people. They're basically nation state, or they're like global states, honestly. Like the Netflix, Google is like more powerful than countries. Netflix less so. But even then, like these big software powerhouse companies exist, and a lot of them are built off the web. Facebook, uh, you know, Facebook is a mostly a software social media data platform, but again, that is like technically it should be possible for people to basically build their own software, their own browser. Like he uses a browser as a piece of software that seems very difficult to for people to build. Let's see. One person can invent the universe. And yes, so if you were to take a look at the browser standards for building a browser globally, it is very, very long. It is thousands of pages. The prospect of getting like building a completely independent browser from scratch today that can follow all of the browser standards, is like, people thought it was impossible. There is one group of people trying to do that right now, basically building an independent browser from scratch, and they are heralded as not necessarily the lunatics, but like kind of crazy people. Like, what? You're building a browser from scratch? What is the point of that? Like, we already have the browser. Like, there's no way that like the thinking about someone trying to write a browser as fast as like Google Chrome, like that's out of the question. As fast as some of the other ones, like Firefox, Chromium, Safari, and I mean, even Chromium, like that's a browser core that basically everyone in the world except Firefox and Safari, I think, was like, you know what? let's just use Chromium. Microsoft tried to write their own browser from scratch with Edge, and then ditched that, and after they ditched Internet Explorer, and I was like, let's just use Chromium as our core, because the prospect of writing another browser from scratch, like the core browser, is just too much. But technically, all a browser is a view. Well, it's basically a running program. It's basically, what if you could create a program that can run other programs? So it has a JS interpreter, has an HTML renderer. Actually, the HTML renderer comes first, where if you have HTML, like an HTML document, like say, HTML renderer, and suppose you had something like doc type, I think it's maybe here, doc type equals HTML, and then I think you close it like that, and then you had HTML, and then you just did P hello, and then /P/HTML. I believe this is valid HTML. If you have a program that can basically render this onto your screen, that is the start of an HTML renderer. If then all you need, or not all you need, but what if you wanted to attach a what if you do styling, custom styling? Let's say P class. I don't exactly remember how to do this. I don't know, but suppose you wanted to do like, font size, like CSS styler, font size, color, animations, flexbox. That's a lot of, gets to a lot of stuff. But again, that's literally just kind of math you can apply, like styling math that basically is like, it turns a window, basically, if you want to write a bunch of windowed software, like, here is, like, I don't know, you want like a tab at the top for like, this can be like your home tab, and it can have a bunch of other tabs. And then how do you specify stuff within that, like positional display, or like percentage displays, like how do you render something in the center of the screen versus like the center of an internal container, and you can like combine containers into interesting ways. All of that is basically just CSS styling, and then JavaScript interpreter. Although this is honestly like optional, like the early, and not optional, but again, the early browsers did like their JavaScript scripting capabilities were very limited, I think. Even then, and then even if they weren't, like JavaScript is kind of like, I've heard it being described as a scheme, a homunculus of some kind, and then curl functionality, web requests. There we go. This is pretty much what you need to build a browser from scratch. It doesn't need to be fully HTML, fully CSS, fully JavaScript compatible. I guess this also has its own dev tools analysis as well, I guess. But I mean, honestly, when you're building game engines and stuff like that, like building your own 3D game engine, scene graph, visualizer, everything, you kind of need to build your own debugger, and you can kind of build the debugger in parallel to the general development. And that's kind of interesting. Oh, speaking of which, there's another tidbit that I heard. I read off of X a while ago, and I'm calling it X because it certainly is not Twitter anymore. It's just the vibe of the platform has significantly changed. No reason to refer to it as what it isn't anymore. But anyways, UIs should have APIs now. Any graphical user interface for any reason should have a easy to use interface that can be utilized by other programs like agents, for example, while the program is running. Maybe it's just the UI itself isn't super relevant, and it's you instead expose the controller or whatever, like whatever handles the state of the program. This so in the whole model view controller paradigm, expose controller and models, I guess. You might not need to. Oh yeah, maybe you actually, yeah, models through APIs. I don't know. Like, I actually had an idea to be able to do that for this cube, where it's like, oh yeah, what if you wanted to pass in the cube inputs as some sort of like, I don't know, either like a JSON format initially or a I don't know, like a scheme data like data file or something. Pass in the arguments for how fast the cube rotates, how zoomed in it is, the renderer format. So if we, and then also an ability for the program to alter the state of the program externally, like from an external command live. So if you wanted to write an agent that would, like, automatically switch between the render modes, or change the speed, or even change the shape if you want to make it like a, I don't know, good enough graphical environment for this stuff. What if that could be done? I don't know, just kind of, obviously this is just kind of me ranting, but interesting to think about. Oops. Oops. For agents. But yeah, I don't know. And oh yes, one of the reasons why I mentioned this talk, should finish your software, is because agents can, like Claude Code, can significantly help with this. Claude Code can help write all of it. Yes. If there's any piece of software that you want to build and you want to see on your computer, Claude Code can help you write it from scratch using the C. Basically, it allows you to invent the entire universe. Not the entire universe, but all software that anyone might want to write at any point. Oh yeah, I guess another part of this talk was stable APIs or APIs. I don't know. And because we have stable APIs and we have Claude Code, um, Claude Code can supercharge this effort. Any stable API that has been developed over the past however many decades, like the last decade, the last 2 decades, Claude Code will almost certainly be able to write code for that. SDL2 is going to live on through Claude Code, basically being able to write code for it. It's a fairly mature, like 13-year old, like 12 and a half, 13-year old graphical library for doing stuff. And, you know, that can work. Like Claude Code knows how to do it. It's not perfect, can't one-shot things or anything, which is why the actual planning process for how the code should be laid out and stuff definitely needs to, like, you need to have that. Again, you can't export the thinking from what you're trying to do, but, you know, Claude Code can help. Anyways, let's actually get into coding. I just went on a fucking long-ass rant there. But get into coding. Let's see, what should we build? I am actually thinking of potentially fooling around with a basic scheme interpreter. The reason is because scheme is easy as hell, and or it's not easy. It's simple. It's a solid language. I believe I've heard. I and you know it's easy to interpret. And there's the whole like code is data. Everything's just a bunch of whatever lines of code. They're like you have access to everything, and being able to basically have a scheme interpreter could be useful for if we just want to ever use the scheme data format to like pass in data that we want. We could build a JSON parser or something like that. But I mean, hey, you know, if we have JSON, actually, no, damn, okay. Here's the thing. I don't necessarily have a goal for this stream at the moment. I want to basically do a bit of Ralph loop prompting. But other than that, I'm not entirely sure. Oh, you know what I could try doing is I could try building a. Actually, you know what? Screw it. Yeah. Let's do a scheme interpreter. The reason being is that if I ever want to try doing any scheme programming or like building browser type stuff or include like have programs that rely on a little bit of scripting, I could try using a scheme for that and being able to pass in scheme as like a little scripting language. Honestly could work fairly well. So let's see. Claude. Now I've looked into scheme a bit. How might I write a small scheme interpreter? Actually, let's see, even before I talk about this scheme interpreter, like what exactly is scheme? I kind of know. I don't really know that much about. It's like the scheme is just a version of Lisp, right? And the Lisp is like what this language from the heavens. It's like has some like purity in the way it works, but um, I don't know. I am interested in writing a scheme, interpreter, and using a scheme as a embeddable scripting language as a way, as a data format for specifying things. Which version of scheme would you recommend I target? Have heard that the sixth standard is a fairly common one. Write me a PLAN.md file for that lays out some design considerations for this interpreter as well as example scheme scripting scripts or data formats I might use for other programs, whether it be game engine stuff or UI programs. All right, let's see what this does. Let's see. Yeah, I don't know. Ooh, I forgot to specify that I want to use scheme or like build everything in C. Basically, that's I don't know. Let's see what it does. I might need to potentially interrupt this, but I don't know. I guess we'll see. Anyways, for something specific that I might be able to Ralph loop prompt into existence, this scheme interpreter could actually work. I mean, a compiler or an interpreter is nothing too crazy. I can make it basic for now. Yeah. From what I remember, Scheme only has like around. Okay, I'm gonna start going into some actual design ideation stuff. All right. Oh, there we go. Oh, well, I guess it knows it has memories. It's saved memories of what I've been doing, so it might have that Already in mind. Okay, chibi scheme. Hmm. Uh, you know what? Maybe I should have just done the research within this Claude Code terminal, because honestly, um, ooh, R7. Okay, R7 small. All right. It has a spec of 90 pages. Lexer, Reader, Expander, Evaluator. All right. Cool, cool. This looks good. Um, let's take a look at this plan. All right. R7RS small. This type of interpreter, broadly small enough to implement. Completely 90 pages spec. Clean module system. All right. Proper tail calls, exceptions, byte vectors, ports, and parameters. All right, that looks good. Superset of R5RS. All right. Optional SRFIs. Don't know what that means, but nah, it's fine. So Lexer, tokenizer, S expression. Oops, this is, yeah, stream has had to pause for a bit. All right, dead stream. Oops. Cool, cool. Yeah, someone was messaging me briefly. But all right, anyways, back to it. So, okay, mark and sweep. Damn. All right, going into so tail call optimization loops. Return a thunk from tail position. Implement in most host languages. CPS. Full numeric tower. Damn. Okay, I guess I'm not, I don't necessarily think I'm trying to Ralph loop an entire C interpreter with like a GC and continuations and stuff. Module system, maybe. Nah. Embedding design, though. All right. This is interesting. Let's see. Register host functions call from scheme. This is interesting. As expressions as a data format. Example, UI application data formats. Damn, wow. But Claude Code really has, Anthropic has really thought of everything. Wow. Let's see, window. All right, title, my application size. Theme, JetBrains one. Oh, cool, cool. Layout, vertical. Oh, it even has key bindings and stuff. Wow. Where is this all from? This must be. Oh, this. Oh my God, this does it for